Hi there, you're in the lab with your mate JJ. Today is Maxitronix Day. Today we're going to do a Maxitronix video. We're working our way through the Maxitronix Sensor Robot 20 Electronic Project Lab. The project that we're up to today is project number 15, Glass Organ. We're going to be making a glass organ, so I don't know anything about that. I'll jump you on the computer, over onto the computer here, and we'll look at the instructions together. Once we've done that, we'll pop over to the booth and we'll assemble the circuit. Once that's done, we'll bring it over to the bench and we'll have a look at it under the oscilloscope, under the thermal cam, and this sort of thing. So yeah, first things first, let's have a look at the instructions. Here on the computer, so let's fire up our web browser. Now got to synchronize, and now I put a link down here. This is project 15 of 20, instruction, schematic, wiring diagram. So this is the this is the whole thing. Let's have a look at what it says. This is project number 15, the glass organ. What it does: most organs have a keyboard. This one does not. It has a touch board, but because your sensor robot can interpret the signals received by the touch board, you can build this circuit and generate tones as if by magic. Salt water conducts electricity. Plain water does not. The greater the salt content, the better the water conducts electricity. The touch board sensor can tell the difference. After you wire the circuit, gather 5 glasses in a circle. Fill each halfway with water. Then put a 1/4 teaspoon of salt in the first glass. Double the amount of salt from glass to glass, ending with 4 teaspoons in the 5th glass. Then, after you turn on the control, dunk the touch board into the water of the first glass and press the key. Change glasses and press the key again. Each glass produces a different tone. Experiment with the amount of water and the amount of salt to get a variety of tones. How it works: when you put the touch board in a glass of water, the voltage between two 10 kilo ohm resistors connected to the base of both transistors increases. When the voltage increases, the charge/discharge cycle of the 0.47 microfarad capacitor increases also. This affects the astable multivibrator. Its frequency rises as well. If you press the key at this point, transistor Q5 turns on and the buzzer sounds, generating a tone based on the frequency of the multivibrator. Cool. So you can see Q3 and Q4 here. This is our multivibrator. It produces the tone. The 0.47 UF capacitors are part of the astable multivibrator here. It mentions a 0.47 microfarad. I think that maybe that's this one, and it's labeled microfarads where it should be labeled maybe nanofarads. Are you seeing that? How many capacitors are in this thing? We've got 1, 2, 3. 1, 2, 3. So 75 and 76. Okay, it says 47 microfarads. So there's a typo somewhere, because these say they're 0.47. This says 47, and this says 0.47. 0.047. So we'll have a look at that when we're over in the booth. And speaking of the booth, let's pop over there. Let's go and we'll put this circuit together. Here we are in the booth. I found this, but this is not the touch sensor, which we do need. This is the voice sensor, which we don't need. The first job to do here is to take out the wires from the previous project, so let's do that first. Alright, so that's done, and I've just left this little wire in here because we always seem to need that particular one. So our next job is to wire up this project, so let's do that now. Alright, so that's all assembled now. The other thing to do is to attach the touchboard terminals here. So we'll do that when we're over on the bench. So let's duck over the bench and have a look at this guy. Here on the bench, and this book that you can see, this is a book my friend lent me a long time ago, and I've been meaning to return it to him, but I wanted to read it before I do. I'm reading it at the moment. You can see I'm up to about there, so I've got most of it to go. I'm going to try and get that done today, actually. We'll see how I go. Now here's our circuit, and we're just going to go digging for our wedge. I use the wedge to elevate it so that we don't get the glare. You see, no glare. No glare is good. We don't want glare. Alright, so there's our thing, and these are our instructions, of course, and as you can see here, the final touch is the left terminal red for the touch board, and the left terminal, it says black, left terminal. So obviously there's a bit of a mistake there. Now, did we figure out? Yeah, right. So it's the mistake that was made was in the labeling of these capacitors here and here. It says that they're 0.47 microfarads, but they're actually 0.047 microfarads. So now we know. The first thing to do is find this. This is the touch sensor that will be dunking into our glasses of salt water. I'll go and arrange for that soon. We'll do the experiment per the instructions. So we're going to need a little bit more apparatus than usual today. We're going to need 5 glasses of water, and the glass is going to have to be big enough to accommodate this thing, which is a big honking thing. So I'll have to figure that out. But we're clever, enterprising people. We'll be able to figure that out. So let's first of all put on the alright. So now if we power this guy up, and I'm just going to throw up my my bench supply here, and I'll run in 9 volts. So it's negative on this side and positive on this side. Now this is a tone making endeavor, so we should hear a tone. Let's see what happens if we put, okay, I'm going to V set 9 volts, enter. Okay, turn it on. This is switched on already, and if I press the button, nothing. Okay, we were expecting to hear something. Alright, well, it's not working, is it? Oh, I've wired the component into the touch sensor. I haven't wired it into, sorry, I've wired it into the voice sensor. I should have wired it in to the touch sensor. So let's just turn it off, and I'll turn the power off on the wall, and we'll fix that error. Alright, so let's try again. We're going to try and put this in here. So I'll just make sure that it's producing a tone, and then when it's doing that, I'll arrange for some glasses of water. So let's first things first, try and get this working. So I'll put the power on, throw the switch on, I'll touch the touchpad over here. Hopefully that's enough. Oh dear, not working. Well, maybe it needs to be higher conductivity. Let's just try shorting it out. Let's see what happens if we do that. Nothing. Okay, we've got the power on. It's not drawing any power. Let's get out the old continuity tester. So I'll just take the continuity tester here, and I'll put it on continuity mode, cycle it through, and then this should give us a beep if the wiring's good. So what we're going to do is just try one side of this on the thing there and see if that... Okay, that's not working. What about this? Okay, I wasn't expecting that. What are we going to do? Let's just see. First of all, oh no, okay, it's not beeping at me. Why not? Oh, of course, it's in the... sorry, I had my soldering iron set up for measuring amps. Should have tested that first by shorting the probes. Okay, that's beeping. Okay, that's what we want. So let's try this side. Yep, that's working. And this side. Yep, that's working. Alright. So, are we missing a joint? That's a bit loose. Let's see if we can do that a bit better. So let's just check the voltage over here. So this should be 9 volts coming in here. Yep, that's 9 volts. So just check all of these joints here. They all look pretty good. Now let's just try... okay, so I wonder, can we just check the continuity of the things for the key? This is one key down there. And what about that? I'm not sure. Let's put that there. Yeah, okay. That key's working. Let's what happens if we short this out? I'm not sure. Alright, there's the touch panel up the top there, so let's just see if that's wired through or not. Okay, there's a problem there. No, that's no problem. Alright. Well, why aren't we getting a tone? What happens if we just short out the touch panel? Just got a wire here. This is the touch panel up the back here. Let's just take it out of the circuit effectively. Actually, I won't use the spare wire. I'll just use the wire itself. Okay. There's no tone. Why is there no tone? Quite a conundrum. Alright, well, I've taken the key out and I've taken the touch panel out. So if there's a multi-vibrator, should be sending a tone through to the buzzer. Well, time to fire up the multimeter. Sorry, not the multimeter, the oscilloscope. So I'm just firing up the scope now, and I'll put the screen on so I can see what's going on. All right. I'll fire up the thermal cam as well. That might give us some clues. Who knows? We should at least see the resistors here warming up in the astable multi-vibrator. So we'll check that out in a second. Now what we're going to be doing here is just trying to see if there's any signal coming out of the astable multi-vibrator or not, because it's not coming through to the buzzer, but maybe it's not being generated at all. We'll see. Now I've just got to put utility I/O HDMI on. All right, and then I might as well. Okay, so I'll just throw you over there. Now we've got to calibrate our scope. So let's hook up a signal first. Where did we want to put it? Let's put it between negative. So negative's on pin 52 here, that's negative. And then we want to see at the base of Q5, that's pin 61 here. So let's put that on there. Base of Q5. Now I'm going to auto calibrate the scope, and we're just getting noise, no signal at all. Interesting. So that's not what I was expecting. All right. Well, there's no multi-vibrator. Well, let's see what happens at the base of our other wow, that's a real mess, isn't it? It's not getting a good signal that it can sort of tune into. Yeah, that's a real mess, isn't it? Okay. And what about down here? Interesting. And let's try. Let's try here. Ah. Yeah, there's nothing really regular about this circuit. Something's wrong, isn't it? I'll be back over there. Look, I'm going to go and make a coffee and think about what we're going to do here. Well, I'm back and I got my coffee. So the multi-vibrator doesn't seem to be vibrating, does it? It's not that it's getting no power. There is some sort of signal there. It's a real mess. So not sure what to tell you about that. What am I going to do? I'm going to check the wiring, and then I'm going to check the schematic to see if there's any discrepancy between the schematic and the wiring instructions, and then we'll be able to continue. So I'll do that now, but I won't record it. I'll be back in a second. All right. Well, I've just been over the whole board, looking for checking the wires as specified in the wiring sequence here. Everything looked good, so let's try again and just see if it's working now or not. Still nothing. And if we press the thing, still nothing. And if we hook on our oscilloscope, what's that going to show us? We're going to try on the base of Q1 again. Something's beeping. What's beeping? Something beeped at me. Alright, let's auto calibrate the sensor. Can I put that on? There we go. So you see, we're not getting a good consistent thing there at all, are we? It's just not triggering. It should be a nice square wave coming through, but that's not what we're seeing. So yeah, I'm really not sure what to say about that. One thing that we might do is I'll just throw you back over here. We'll put this onto resistance mode like this, and we'll just see. I'm not sure if the touch sensor, if it's capacitive or capacitative, or if it's resistive. I'm not sure. So it's reading 3.8 kilo ohms, and if I touch down on it, still registers 3.8 kilo ohms. I'm not sure if this has a capacitance. Oh, it does have a capacitance tester. So let's put it into capacitance mode, and it's showing no capacitance at all. And if I touch it, okay, so I think that it's resistive. So let's pop back over here. When I touch it, what about if I just literally short it out with a bit of metal? Here's a screwdriver. I'll just short it out. Doesn't seem to be working at all, does it? It's a resistor, but it doesn't. Oh, there we go. So if I short out the probes, the resistance goes right down. I wonder if I wet my finger and touch it. Yeah, right. That does affect it a little bit. So if I lick my finger then I can get it to drop a few hundred ohms. So this is effectively functioning as a resistor. What I might do is, well, actually we can do it together. I'm just going to turn this off for now. Now that was a 3 kilo ohm resistor that we measured there. So what we'll do is we'll just, I'll just put this away for now. What we're going to do is get a resistor, 5 kilo ohm potentiometer. So let's look in the drawer. Oh dear me, I don't have 5 kilo ohm potentiometer. I've got 1K, 10K, 50K. Okay. Alright, give me a second. Here we are on the computer just quickly. I don't have any second will work. No. Potent. Let's pick that one. Alright. 5 sets. Okay. They look fairly good to me. What do you reckon? Alright. And we want 5K. Now, I'll just check the drawer. Can you see that? Yeah. That's my drawer of 50K potentiometers. And I've got 1, 2, 3, 4, 5. Looks like I've got 10 of them in the drawer. So that's what I'm going to do here. I'm going to get 5K times 2, add to cart. So that's all well and good. It's trying to upsell me on other stuff. Let's go to cart. It's opened it in a new window. Alright, shipping is $2.99. Is that all we're gonna do? I could do another one of these boxes and bump the price up and get free shipping. Let's add to cart and see what it says. What have I done? Got windows everywhere. There we go. It's not going to charge me shipping if I buy an extra thing. So I've got 10 5K resistors and a little electronics box of bits and pieces. Yep, I'll go and check out now, and then I'll go back over and we'll just use a 10K pot for now. Alright, so I ordered myself some 5K pots. I've got a space for them in the back of this drawer here, which has my my 50K pots. Can you see that there? That's my 50K pots. What I'm going to do is put these in the back here, and then make a space up the front here for the new 5K ones, which should be arriving. And we're going to want that 50K pot label to be on the top, and then there should be a 5K potentiometer label for the bottom part of the drawer. So let's move that, and we're going to put in 5K potentiometer. Did I get that right? Oh, I had my caps lock on. That's not what I want. Potentiometer. Alright, so I'll just print out one of those, and there will be a spot in the front of my drawer for when those arrive. And when I was there, I just got a little extra $12 box of goodies. Comes with resistors and capacitors and bits and pieces. It's good fodder. Good fodder for the lab. Cheap as chips. So, now the closest to 5K that I have at the moment is 10K. So we'll just use the use the 10K while we wait for our 5Ks to arrive. Now we're going to want to put some jumpers on this guy. So first of all, we'll just make sure that we've got it the shouldn't have put my thing away. I'm going to need that. Just going to switch out the probes here. These are the pointy ones, but these are better for this job. So we're going to put it back on ohms. Pop out the thing. Can you see that? Yes, you can. All right. Now what we want to see is we want to see this go from low resistance to high resistance. So we put it all the way down on this end. Okay, that's maximum. And if we turn it this way, that's minimum. Okay, so what we want is this side to this side, so that it's minimum here, and we turn it clockwise to increase the resistance. That's what I want. So those are the two that we need. We need the one on the left and the one in the center to get it operating the way that I think is intuitive. So what we're going to do is I'm going to fire up my soldering iron. I need a soldering iron for this job. And I'm going to get some jumpers. So we're basically just going to want two jumpers of the same length. These great big honking ones ought to do. What do you reckon? Two yellow ones? Yeah? I don't know. I could just use one yellow one and cut it in half. Do you reckon that'd do? I'm not sure. I take one yellow, and if we cut a yellow in half, it'd be about that long. Decisions. Or we could use two yellows and get it considerably longer. I'm not sure. Now, is this labeled 10K? It is. Okay, good. Well, what I'm going to do is I'm just going to use half each. I'm going to use a long yellow one, cut it in half, and solder one end to each terminal there. So where's my old trusty? These are my favorite. This is the best bang for your buck equipment you can get. Go looking for these. You can get like 5 of them for $5 or something silly. And they're the most useful things. Super, super fine, very flat, just what you need. So there we go. Now we're going to need a wire cutter. I've got one of those here. And we're not going to need too much wire, so let's just, what is this, you reckon? Let's say 26 gauge, I reckon. There we go. And we'll do the same on the other side. 26 gauge. There we go. Alright, now, are we going to need magnification? Probably not. Let's twist the wires up a bit. Alright, well let's do the one at the back first. I've got some solder here. And let's just get ourselves a bit of an angle there. And let's warm up the thing. Alright, well, maybe I need to use my third hands. I think I do. Yeah, let's use our third hand. I've got them all over the place, these things, but here's one. So, just get our solder here. Alright. Well, can you see that? Yeah, you can see that. Okay, cool. So let's just send the wire through there. And we'll put that on there. Let's just move that around like that. Very good. All right. All right, that looks pretty good to me. Get our solder. Little bit of heat on the joint there, and chuck in some solder. It's pretty good to me. And let's do the same but on the other bit of wire. Fairly good to me. And let's looks fairly good. Should have put some heat shrink on the wire before I did it up, but I can probably just use a bit of heat shrink to go over that. Let's see what I've got in the drawer. This is my heat shrink drawer. I do actually have oh, I just dropped my third hand here. Alright. Let's put that away. Alright. So, yeah, I should have used a little bit of that yellow there, but what about this yellow here? That looks alright. Let's pop this out, and what do you reckon? Maybe these too small. They're the ones I should have used. Anyway, can I get that through there? Nearly. Yeah, it'll go through. Alright. Well, I wonder, you know what? I'm going to do it properly. going to use this bit of yellow here, this bit of yellow, and we'll redo the soldering, and we'll just do it right, huh? So we're just going to use half of that, 1/2 on each side. So I'll just cut that in half there now. Looks about right to me. Alright, so we've got 2 bits of stuff. We're going to have to undo our soldering, that's no big deal. Just heat that up there and off he comes. Alright, now we're going to need to put on our heat shrink. Put it all the way up there. We're going to need to get that third hand back. So let's do that. Here it is here. Now, let's get the wire in, and we'll just do what we did before. Alright. You know, I might just get a little bit of Fluke tape. Just a bit of blue tack here. I'll just stick the thing on, and there we go. Looks pretty good to me. Gonna need a little bit more solder. That looks pretty good to me. And we'll just do the next one. All right. Alright. No. Just gonna put a lot more solder on there. Alright. So, if we give these a bit of a test, that seems pretty good to me. Now I'm just going to throw on the hot air gun. Put that on together. Alright, now we'll put the heat shrink over the top there. Gonna not need that blue tack anymore, I'll get rid of that. And I think we're done with our third hands, so they can go away. And we're gonna need to just heat up the heat shrink here so it protects our joints. Probably wasn't super necessary, but it'll be good. So this is my my hot air gun, you can see here, set at 380 degrees Celsius. There you go. Let's give it a bit of a heat up. Pretty happy with that. So put my hot air gun away, turn him off. Alright. Now the final test is to just hook up our our resistance meter, our ohmmeter, which is my Fluke 17B plus here. Alright, so we can go down as low as 3.5 ohms. Can you see that? Let's put that somewhere where you can see it. Maybe you'll see it better if I do it like that. How's that? Alright, so it goes as low as 7.8 ohms, and I should be able to turn it and it'll go up, so that's at 2 kilo ohms, 6 kilo ohms, 7, 9, and it goes all the way up to 9.69 or 9.7 kilo ohms, which is basically the full 10K that it's rated for. So let's set this at, well, it doesn't really matter, but let's set it down where the other thing was rated around 3 kilo ohms or so. So that's what that's set to now. I'll just turn him off. We don't need him for the moment. So let's get rid of that glare for you, the little wedgy bit. Alright. Now, as we measured earlier, the resistance on this thing was about 3 3K. So how are we going to do this? Well, what I might do is just use one of the empty pins here, and then put in the resistor, the potentiometer, between here and here, and then if I just throw all of the power on, and if we change the resistance there, it doesn't affect it in any appreciable way, does it? Turn it up, turn it down, turn it up, turn it down. No tone. Well, we've certainly had our astable multivibrators generating a tone before, so the fact that this is not generating a tone is really quite odd. Let's keep this circuit together. Okay, well, the next thing to do, I'm just going to buzz out all the wiring, and we'll just see that all of the wires are creating reasonable joints. So for that, we're going to have to go back over to the multimeter, and we're going to put him in continuity mode. There we go, and we're going to need our proper probes. So let's get those. Now that's on common and that's on positive. We should get a beep if we put them together. Alright, what I'm going to be doing is just buzzing out the terminals. So that was 1 to 3, and then I've got to do 9 to 62, 9 to 62. Alright, and that's basically what I'm going to be doing. So I'm going to do that now. You can watch me do it in time lapse. Well, good news and bad news. The good news is all the wires buzzed out correctly. The bad news is It's still not working. Still not working. What will we do next? I'll have to have a close look at the schematic and see if there's a wire missing. So I'm going to do that now. I'm going to have a hard look at the schematic and see if there's a wiring that seems to be missing. So feel free to have a look yourself. I'm going to be having a close look. I'll come back in a second. Alright, well, if you look through here in the wiring sequence, conspicuously absent is pin 4, which is the other side of the power button. So they've got they haven't wired in the power control. So yeah, that's obviously a major problem. So I'm just going to turn off the power. I'm going to turn off the power, turn everything off, and then I'm going to add a wire that was missing here. So that needs to go into here. And if that was the only bug, then we found the problem. And it wasn't an error of mine. There is no join for pin 4. So hopefully that's the only mistake that they've made here. And you have to wonder, don't you? I mean, do you think they did that on purpose for learning purposes, or is it just a bona fide mistake? Who knows? Who knows? Anyway, let's throw the power on. It's on. Turn the on. It's on. Yeah, baby. We press the key and we get a tone. And the other thing is we should be able to test, but if we touch this, it should get a different sound. Yep. Yep. You can hear the finger affected. So it called for 5 glasses of water, which is actually quite demanding, isn't it? I'll just move my tools here. These are my tweezers, and I'll put this up the back here. Alright, what are we doing? I'll just put my wire strippers away. We're done with those. Let's put this right at the back there. Now, are we going to need the multimeter? No, I don't think we do. So I'll just put him away. We're going to need to get 5 glasses and a spoon and a thing full of salt, of all things. Now I don't think I have salt. I have bicarb soda. Do you see? I have some bicarb soda which I was using for probably cleaning stuff, I'd imagine. Anyway, I'm going to do the same. I'm going to get myself a jar of salt. So we've got a jar of salt, 5 glasses, coming right up. I'll organise that now. Alright, well, I found 3 glasses, that'll do. And I also found this jar, but it's got an old label on it. I'm going to try and take that off. So let's do that together now. Alright, so that's most of the label taken off. But there's still some grotty looking stuff on there. So I thought I might try and hit that with the old Goo Gone. Pretty good stuff, this Goo Gone. Not sure how we're going to do it. I'll use my dirty brush. This is my dirty brush. Can I do this here? I don't know. How will we do this? What I'm going to do is take the lid off here. The Goo Gone kind of attacked the nozzle, so this isn't a spray canister anymore. But if I get some on the cotton tip here, and just give it a bit of a rub. We should see if it's going to work or not. Yeah, that looks pretty good to me. So what we might do is just load up one of these glasses, huh? With a bit of the old goo gone. This is good stuff, this goo gone. Hopefully I don't knock it over. This is a spill hazard. Alright, well I'm going to use the Q-tip and the goo gone, and then I'm going to come through with a tissue. And that ought to do it, I reckon. That looks pretty good to me, don't you think? We'll just keep doing that around the whole thing. Alright, well I'm just going to time-lapse this and I'll be... Alright, so we've got one clean jar. I'll go and get some salt for that. I'll tip that out and I'll just put this back. If you haven't heard about it, this stuff is called Goo Gone and it's really good stuff. I'll show you the bottle it comes in. This is the Goo Gone. You need to buy it from America. I'm pretty sure I got it shipped internationally. But I've never used anything that's quite as effective at removing sticker gunk as this. It's really good at cleaning up messes. So certainly happily recommend Goo Gone. Check it out. Now I'm just going to go and finish up with this mess here. I'll be back in a sec. Alright, I'm back and I've got all sorts of bits and pieces. Over here is a glass, a beaker full of water. I've got 3 glasses here ready to use, and I've got this jar. Now the first thing I'm going to do is and I've got this from the kitchen. It's a jar, a jar full of salt. So I'm just going to label this salt. Do a little bit of housekeeping here while we're at it. So there's my glass and here's my label. Alright. Now in the... I'll just put the label on. In the bottom of the salt jar, I'm just going to put some silica gel. I've got some silica gel. I think I have 2 of them actually. Where's my other one? I thought I had 2. One will do. I thought I had 2. That's annoying. I'll go and get a second one. I feel like 2 is the right number. So I'll put 2 there. Now I'm going to need a spoon. I didn't bring one. I'll go get it. Alright, I'm back and I've got a spoon. Oh, there's the magical other one that I lost earlier. Fair enough. Now, I'm not sure if you can just pop this off or not. Doesn't seem like it. So what we're going to do is just try and get some of this alright. Well, I'm going to time lapse this. Alright, here we are. And we've got a a jar full of salt. So we've got a spoon for spooning out the salt, and we've got 3 cups. We've got a circuit that makes a tone. Now I might just prepare to splash a bit. Let's put those there. Alright, we've got 3 cups. Now we're going to need a stirrer. So one of my spudgers will do the job nicely. What about this one? Look at that, that's got a fancy end. We'll use that for stirring. Now what we're going to do is 1, 2, 3 spoonfuls. Now it did call for 5 cups, but there was only 3 of these little cups that I could find. So let's just call that 1, and then call that 1 and 2, and then we're going to do 1, 2, 3. Okay, so I don't know if we should expect to hear a different tone based on these portions of water. I'm going to fill them all up to about, say, there. Might actually go just a bit further. Alright, let's give them all a bit of a stir. I think we can do better. We can do a better spudger. Just going to dry this one off on my shirt here. I'll find something that's better fit. What about one of these old chopsticks, huh? So let's get right down to the bottom there. That's saturated. I think it's got salt that can't absorb. It'll be interesting to see, won't it, if this produces different tones or not. So let's give it a go. Alright, here's our dunker. So if we press the thing on, we get a tone. Put it in there. Okay. Well, I have to say, I can't tell the difference between those tones. I think the problem is that we've got just way too much salt in there. What I'm going to do is I'm going to take this one, which has got 3 things of salt, and I'm just going to empty it completely, and then just put in plain water, and we'll test plain water against salty water. So I'll be back in a second. Alright, I'm back, and I just emptied this this jar here. Man, it had all sorts of salt down the bottom. It was just chockers full of salt. So I think we didn't use big enough cups, I think. So what we're going to test here is just pure water versus salty water. So there's our tone. Alright, I'm going to put just the tiniest little bit of salt in our pure water. So let's say about that much, huh? It's not very much, I don't think. But I'm not an expert. Give it a bit of a stir. Alright, here we go again. Yeah, okay, I'm convinced. The saltier the water, the higher the tone. I suppose what we could do is look at the resistance. How will we do that? Just a bit anxious that I'll knock this water and create a situation. Don't want to do that. I'll just grab my my multimeter here, and we'll put it on to resistance mode. Put it on resistance mode, and we'll get our hook clips, and we'll just hook on to the I'm just going to turn this off, and I'm just going to put this across the touch panel. Oh. Can you see that? Alright, so we're rocking at about 4.5 K. That's in the salty water. It's changing a bit, isn't it? It's coming down. Look at it come down. Wow, it's coming right down. I wonder when it's going to stop. I might actually just take out these other parts of the circuit, because that could be affecting things. Yeah, it is. Dear me. Don't want to do that. Okay, again it's coming right down. Tell you what I'm going to do. Disconnect this, disconnect that. I'll just put this back how it was with that there. And what I'm going to do is unscrew these terminals here. Just take this out completely, and I'll hook it up directly to the multimeter here. This is my Fluke 17B Plus digital multimeter. It's in resistance mode, and it's jumping all over the place, isn't it? Alright, so let's see where it settles. Okay, it seems to want to be around 5.4. It's going up, up, it's going up. That's interesting. 5.8, 5.9. I don't understand why the resistance is changing like this. Anyway, it's about 6 at the moment. Let's put it in the, take it out of the water. Goes down to about 2K. Put it in the clear water. It's gone down even further. Okay, it's coming back up. It's coming up to 2K again. Alright. So let's put it in the mildly salty water. Oh wow, what's it doing? It's all over the place. 1.4, 1.7, it's going up. I wonder how long should we let, I don't understand why it keeps going up. Put it in here. It's going up pretty rapidly. Isn't that funny? So that's about 4 kilo ohms. And if we put it in the clear water again, it goes down, it goes up. It's going to settle around 2K again, isn't it? So the purer the water, the more the that's interesting actually. I was expecting it to be the other way around, that the salty water would conduct better. I can't account for what we're looking at here. The salty water goes up to 4K. The clear water strange. I wonder if we just did some just dead set pure water, no salt. Let's try that. So I'll just empty this one into here, and then I'll just get a tissue and pull that salt out. That was a lot of salt in there. Alright, that's one tissue. I'll give it another wipe out. We want 0 salt in this thing. And then we'll just put in some clean water, which is here. Alright. And we'll fill him up. There he goes. Now, let's see this. This is Fluke. It's weird. It goes all over the place, doesn't it? Anyway, we'll take him out. Might give it a bit of a dry off as well. I'll see if there's any salt residue still on this thing. Alright. So, should pick up any of the salty water that's still on this thing. Now let's put this thing in clear water, and what we want to see is high resistivity. So it should go up above 4K, for instance. So let's see. Is that 3? It's heading to 4, 3.7. It's up to 4. I don't understand why oh, look, it jumped up to 8. I can't account for this. I don't understand what we're seeing. It's odd. Anyway, that seems to be conducting at about 3.8 kilo ohms. 3.8 kilo ohms. 3.9. It's still going up. I don't understand. 4. 4.1. I'm going to go make myself a coffee. I'll leave this and we'll time lapse it while I make it. Alright, well I went and I made a whole coffee, and this is just silly. It's just going up and up and up and up and up. It's still going up. So it goes up about, what is that? That's about 10 ohms a second. It just keeps going up, 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 up. So I don't know how long we should sit here watching the resistance increase. I don't know why it's increasing, but it is. So I'm going to take it out of the clean water. The resistance has gone up to about 100 ohms. 100 kilo ohms, I should say. It's going up, 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 up as it dries out. That's fair enough. Now I'm going to put it in the salty water, and it's going to come down. Wow, it's come all the way to 0. Wasn't expecting that. Okay, it's come down to about 1.7K. Now in the clean water, it got up to about 7.8K. But I don't know if we left this sitting here as long as we watched the other one. Is it going to just keep climbing up there as well? I don't know. I just don't know. The problem with not getting a reading that will just settle down to an actual value is we can't really compare them, can we? Because we didn't leave this Maybe we need to consider the rate. How about that? Let's do that. So let's say that we'll give it, say, 30 seconds. And Siri can do that for us. So what are we going to do? Take it out of the thing. Just going to clear up a jar. This would be for rinsing. It'll be a rinsing jar. Just got to get the salt out of it. Alright, well, some fresh water here. So we're going to have the fresh water in the middle for cleaning off the thing. Give it a dunk and give it a bit of a wipe over. So let's do the salt water first. So, hey Siri, set a timer for 30 seconds. Alright, we're away. So let's give it 30 seconds and we'll see what the reading is after that. So 30 seconds isn't a terribly long time to wait. You can see this going up, 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 up. And when the beep beeps, I'll hit the hold button and we'll just use that as our value. Alright, hold, and I'll just, okay. I think I accidentally reset that thing. Okay, so, I've got a notebook here, and we'll just make a note. This is, salty is, salty 3.338 kilo ohms. That's after 30 seconds. 30 seconds. Alright, now we'll just clean off the salt water. So we'll give it a bit of a dunk in there and then a bit of a dry with the thing, which is the same way we prepared it last time. Alright, we'll ask Siri for another 30 seconds. Hey Siri, set a timer for 30 seconds. Alright, and it's away. So we'll take that off hold. Off hold. Alright. Gee, it's going all over the place, isn't it? Can't account for this. It's jumping everywhere. Really odd. Alright. Well, I don't have any confidence in these results. But per the letter of the law, we had 30 seconds for the salty water. It got up to 3.338 kilo ohms. The same period of time, about 30 seconds, the clean water got up to 3.67 kilo ohms. So technically, just the salty water was lower resistance than the clean water, which is what we'd expect, but I would have expected the ratios to be quite different. And those numbers, did you see them? They were jumping all around from 0 to 8K, like it was just going all over the place. So I'm not sure really what to tell you about that. But I think we're done with our water here now. Now that we've fixed that problem with the power that was preventing us from getting a good signal earlier, we should be able to use the oscilloscope now and get a good reading on the astable multi-vibrator. So what I'm going to do is I'm just going to clean up here, and I'll be back in a second. All right, I'm back, and we've tidied up a little bit here now. Now I just put this back in plain view. I might also try to hook you up with the thermal cam here. I'm not seeing the thermal cam. Why am I not seeing the thermal cam? That should be coming through. Just give me a second, I'll be back. Alright, so what I'm going to do now, I'm going to throw on the power. I'm going to turn that on there. Okay, we've got a tone. And we don't have... What did I do with our thing? Okay. So I'm just going to wire in our potentiometer from earlier on. I'm just going to take this and put it here. And then I'm just going to just put this in here. And here. I've got someone speaking in the other room. I'll just close the door. Hang on. Alright, so I've wired in our potentiometer. So we should find, if we press the key and we turn the potentiometer, we can vary the signal. Actually, you know, I'm not sure exactly let's just pop him in here and let's get a longer cable. Is that long enough? It's just long enough. Alright, cool. Well, that potentiometer, we've just switched it out for the potentiometer that's on the board here. So this is the one now. So we hold the key down and we can use the thing here to adjust the pitch. Now that is mimicking the salty water from earlier, which affected the resistivity. We've just literally put a variable resistor in the circuit to switch that out. And the reason we've done that is I want to throw you over to the oscilloscope now. Just throw you up there. That's the scope up the top of your screen. And I'm going to put this across Q5. And I'm going to put it across the base and the collector. So that's the collector, and this is the base. And then what I'm going to do is I'm going to auto tune the circuit, and I'm going to zoom out a little bit. There we go. And I might I just go measure, add, frequency, and that's done. So you can see the frequency there is 620 Hertz. Okay. Now, if we press the button, oh, it does affect the circuit a little bit, but not a huge amount. If we just put the display, show scale on. There we go. So I'll put the scale on, and go up, 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 up. Yeah. All right. So the key thing there is the frequency. It's called frequency 1 down the bottom of the scope. I might be able to actually show you. If we just throw it over there, and you'll be able to see the whole thing. So what I want to show you, so as you can see, at the present time, there is no tone, but there is a signal. So that's important to understand, I think, is that we don't stop the signal and start the signal. We just connect it to the speaker and disconnect it from the speaker. So that's, I was surprised to learn that. So this, this signal that you're getting now, you can't hear it. When I press the button, then you can hear it. I'm going to press the button now. And you can see that having the speaker in circuit actually changes the details of the signal just a little bit. Not a whole lot, mind you, but just a little bit. Now, what I want to do is I'm going to press the key, and I'm going to change the resistance, and you're going to hear the tone change. And when the tone changes, the frequency of the measurement on the oscilloscope here will go up. So you watch that number down the bottom left-hand corner of the scope that says frequency 1, and it should go from 600 kilohertz. It should go up and down around that value. So here we go. There we go. So that's at about 1.1, 1.2 kilohertz, and we can turn it right down, 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 down. And we've gone all the way down to about 588 hertz. And we'll wind it back up again. And you can see that, oh, there we go. So if we go too high, what does it do? It actually turns the power off. If we go any further to the left, it'll switch off. So 1.57 kilohertz is the maximum signal that we're going to get through there. And isn't it funny to see? Look, there's a little bit of a ripple there on those. It'd be fascinating to know why we're seeing what we're seeing there on the scope at the moment. But if I just adjust that resistor, you can see that the signal frequency being affected. And it is only the frequency, mind you. The other characteristics, particularly the amplitude, they don't change much. But there is that amplitude ripple that's very discernible, that low frequency ripple. So I don't know what to tell you about that. Okay, and before we finish up, let's jump over to the thermal can together. Here's the thermal can. Now, what are we dealing with? We've got, it's hot there because I've been pressing the key. So the pressed key, that's warm because of my hand. There's something that's really quite warm. Where is that? Here. Ah, fascinating. Okay. So you can see the round circle there that's warm. That's the control knob for the resistor, and I was holding that so it got warm. It seems like, which one is that? Is it that one? No, it's that one. Maybe. Is it that one? Could be. One of those resistors is getting quite warm. I don't know which one it is that's getting warm, but one of them is, compared to the others particularly. So I'm not sure which one it is. And you can see in the bottom left there, and there, those are the resistors in the astable multivibrator warming up as well. So you can see that astable multivibrator, even though it's not actually generating the tone because we haven't pressed the key. You need to press the key. It's still using heat because the energy is going through the resistors, and it's still generating the tone, as you can see on the scope. Well, you could see it earlier on the scope. It's still there on the scope for me. Is there anything more to learn from this device? We've had a look at the thing under the scope. We've had a look under the the other thing to tell you, it's drawing 16 milliamps at the moment. 16 milliamps, and if I engage the circuit, it goes up to 21 milliamps. So it's using 16 milliamps in its idle state, and it goes up to 21 milliamps when it's making a tone. I'll adjust the frequency of the tone. That's quite fascinating, actually. I might even show you that. Let's do it together. So I'm just going to use the the scope, and I'm going to put it on. I'm going to put it on microamps, no, milliamps. And I'm going to need to put this here, and we're just going to intercept the let's intercept the positive power. Alright. Now it is fun to see the difference between what the scope I'll throw you back over to here. Now on the power supply it says 15 or 16 milliamps. Over here it says 17 milliamps. And that's just as is. Now you can't hear anything at the moment because the buzzer is not engaged. But if we adjust this potentiometer here, it will affect the astable multi-vibrator straight away, and it'll actually be visible here. So I'm just going to adjust the thing. I'm going to put it all the way up, and it's drawing now only 11 milliamps. And when I turn this right down, it goes all the way back up to 17 milliamps. Actually, I'll throw you over to the oscilloscope, so you can see that oscilloscope still giving us a measure of the frequency. And when I turn it down, you'll see that the frequency change on the scope there. So when it's high frequency, it actually draws more energy. At the lower frequency, it draws less less current. Isn't that interesting? And when we engage the circuit, it goes up from 11 to 16. So it's 11 goes up to 16, and we should see the same down here. It goes down to 17, and it goes up to 22. So isn't that fascinating? I think that's fascinating. Okay, is there anything else to tell you about this circuit? I suppose the only other thing that's of a little bit of interest, if we just take the scope off, take the meter off out of the current mode, and we'll put it over into voltage mode, DC voltage. I want to show you the voltage across well, let's just see. Oh no, yeah, no, there's nothing really to show you there. This is literally engaged by a switch. That I was going to show you the voltage trigger the switch, but this switch is actually a mechanical switch. It's not a transistor switch, so there's no real thing to show except for the signal on the base of Q5. That's what we're looking at in the oscilloscope just there. So Okay, I'm pretty sure I've shown you everything I can think to show you about how this circuit behaves. So this one was quite a big job, wasn't it? Anyway, we're done. So I'll throw you over to the farewell cam and we'll wrap up. And that's a wrap. So yeah, the experiments are getting better and better and better. I was really pleased with this one today. I thought that was great. I guess technically the salty water, that wasn't really interesting, was it? I mean, we couldn't get a really good distinct difference between salty water and clean water. You know, yeah, I don't know. And the fact that voltage just wouldn't settle into sorry, not the voltage, but the resistance on the multimeter there, it just kept on floating up and up and up and up and up, and I left it for 5 minutes while I was making a coffee, and I came back and it was still going up and up and up and up and up and up. So I lost patience with that. So I don't understand really how the saltiness of the water really affects that device at all. I didn't understand the behavior of the device. I don't know what it was about that circuit that the resistance continually increased. I don't get it. I don't understand. But I don't care to understand either. I'm not super interested. I was very pleased that we found the mistake in the wiring diagram. I should actually make a little note. I'll make a note about that. Actually, let's do that together now. I'll make a note. Let's make a note. So here we are back on the bench, and we're just getting ready to wrap up. So I'll turn that off, and I'll turn that off, and I'll disconnect that, and I'll disconnect this, and we'll get rid of him. So put that away. All right. Now, the thing was, we needed to connect pin 8 and pin 4. So is that right? Let's just confirm. That's 8 and 4. 8 and 4. All right. So let's say warning needs pin 4 to 8. There we go. So we've made a note for future. I suppose I'll try and make a note about that in the show notes for this video as well. So let's just throw you over again to the farewell cam, and we'll actually wrap up. Okay, it's a wrap. So yes, as I was saying, I really enjoyed this circuit. It was great. It was a little bit of a challenge because we had to buzz it out and try and find what the problem was, and of course they made that mistake, so we found the mistake, we fixed the mistake. That was good. We got to see the thermal behavior, which I thought was interesting. You see the resistors in the A-stable multivibrator, they're always chewing some juice. It was fun to use the ammeter to check the current draw. It was fascinating to see that the current draw is dependent on frequency. The higher frequency drawing more current. Very interesting. And we got the oscilloscope working for our signal, which was really excellent. So yeah, all in all, a very successful project, this one. I think it was probably our best circuit so far, although the one that we did the other day, number 14, was also quite good. So yeah, getting better and better. Look, I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.